So that became the language that we used in statistics, splines. Suppose we could fit a flexible curve to the data so that we can have as many inflections or changing first derivatives or changing second derivatives over many different parts of the curve to which we're fitting the data.
Wouldn't that complicate things computationally?
No.
No.
It turns out. It's quite common for people to do studies where they fit wages to age for both male and female groups, like we just went through a couple of those examples, in which case you would get different slopes and different intercepts. But one of the things that we know, that we think we know from labor economics, for example, is that the relationship between earnings or wages and age is very nonlinear. So even though it's nonlinear, we still might have the notion that we could fit 3 straight line segments to the data. So at early ages, your wage rises very slowly. Once you reach 18 and you get out of high school, you've got that precious high school diploma, your wages, with increasing age, your wages rise pretty quickly. And beyond the age of 22, you get out of college, the rate of increase in your wages rises more steeply. Now, we would hope that the straight line segments showing the rate of increase of wages with age is still a continuous relationship. So you can't have any discontinuities at the breaks of 18 and 22 years. You don't want to be able to take your pencil, you have to be able to take your pencil off the paper in order to connect, in order to do the 3 line segments. So then, the question is, how do we specify a model that will accommodate that affair? Well, we could set up, what we're entertaining is 3 regression lines. There's one that says that the intercept is A0 and the slope is B0 if you're under 18. If you're between 18 and 22, the intercept is A1 and the slope is B1. If you're over 22, the inequality runs the wrong way here. It's A2 and B2 are the intercept and slope respectively. Okay, so you've got to be over 22 to fall into that last group. Well, as I just mentioned, we need to preserve the continuity constraint. We want the different line segments to join up. So a dummy variable structure to accommodate that is to create 2 dummy variables, D1 and D2, and we'll specify our model as beta 1 plus beta 2 times age, gamma 1 times D1, gamma 2 times D1 times age, and so on and so forth. And so now, suppose we're looking at somebody who is under 18, then the incremental effect of another year on their wage is just D2. If we've got somebody between 18 and 22, then the incremental effect of another year for that person is beta 2 plus gamma 2. And the marginal effect of being in the third group over 22 is beta 2 plus gamma 2 plus delta 2. However, we said we want to make sure that the join points connect to one another. So we have to be able to make sure that the fitted value of y as we approach 18 from the left is equal to the fitted value of y as we approach 18 from the right. We have to make sure that the fitted value of y as we approach 22 from the left is equal to the fitted value of y as we approach 22 from the right. So we have to estimate our wage equation subject to the constraints that the line is continuous at the join points. Okay, so it's a pretty simple thing to do. It's not hard to do this. Turns out, and I think Hone is doing it for his project, turns out you don't have to constrain yourself to straight line segments for these spline functions. You can do polynomials of differing degrees over the different intervals on the horizontal axis. And you just have to remember what the constraints are as you're approaching the join point from the left and the right, and make sure that the line segments touch each other at the join points. Again, it's not hard to do. The seminal article was in the Journal of the American Statistical Association in the early 70s. There's been a huge literature since then on splines, and fitting splines is now a regular part of SAS and SPSS and R, because everybody's really interested in nonlinear functional forms. I think we'll skip there's an example here of the dummies and splines winning times at Indianapolis 500. So the example that's here is